May 3rd, 1990. A tornado forms over Oklahoma. At first, it looks like many others, but radar operators notice something unusual. Velocity values are climbing. 100 miles per hour, 150, 200. Then the numbers keep rising, accelerating beyond anything meteorologists have ever measured inside a tornado. A mobile radar truck scans the storm, 301 miles per hour. A mobile radar truck scans the storm, 301 miles per hour. This rotating column of air is moving toward Oklahoma City, poised to carve a path more than 30 miles long. Over the next 90 minutes, entire neighborhoods will be erased, thousands of homes destroyed. Over the next 90 minutes, entire neighborhoods will be erased, thousands of homes destroyed. May 3rd, 1990, began quietly, but by late morning, meteorologists knew the atmosphere was dangerous. Warm, humid air from the Gulf of Mexico, high temperatures, and rising dew points created extreme instability. Instability alone isn't enough. The key was the extreme wind profile stacked above it. Wind shear, the change in speed and direction with height, allows thunderstorms to rotate. By early afternoon, computer models and radar trends aligned. The Storm Prediction Center issued a rare, particularly dangerous situation tornado watch. The Storm Prediction Center issued a rare, particularly dangerous situation tornado watch. Across central Oklahoma, towering storm clouds began exploding upward, forming supercells, rotating engines of rising air. Each supercell contains a powerful updraft, generating its own rotation that can tighten into a tornado. By mid-afternoon, storm chasers positioned along rural highways, Doppler radar scanned, and forecasters issued the first tornado warnings. By mid-afternoon, storm chasers positioned along rural highways, Doppler radar scanned, and forecasters issued the first tornado warnings. One storm southwest of Oklahoma City was about to become the most violent tornado ever measured. Something powerful was beginning. By mid-afternoon, the sky over Oklahoma showed not ordinary storms, but supercells capable of producing the most violent weather on Earth. Around 4 p.m., the first tornadoes began touching down across the state. Storm chasers reported rotating wall clouds beneath dark, lowering bases, and radar operators saw hook echoes, signatures of twisting updrafts. Warnings spread rapidly. Sirens activated. Schools moved, students and businesses closed as the sky turned an uneasy shade of green. Meteorologists noticed one supercell southwest of Oklahoma City, strengthening far more quickly than the others. Inside the storm, winds fed a powerful mesocyclone, a rotating engine stretching downward toward the ground. Near Chickasha, storm chasers watched as dust swirled beneath the lowering cloud base, and the first condensation funnel appeared. Within minutes, the circulation tightened dramatically, and a tornado touched down near Bridge Creek, Oklahoma. At first, a narrow column, the tornado began to grow as the storm above it continued strengthening, its circulation widening quickly. At first, a narrow column, the tornado began to grow as the storm above it continued strengthening, its circulation widening quickly. Around 4:30 p.m., the tornado near Bridge Creek began changing shape. What started as a narrow funnel rapidly widened into a massive triangular wedge of rotating debris, stretching from cloud base to ground. Storm chasers realized the danger immediately. This was not a brief tornado. It was strengthening. Radar velocity scans confirmed extreme rotation as the mesocyclone tightened, dropping pressure sharply. Homes near Bridge Creek took direct hits. Roofs peeled, walls collapsed, vehicles were thrown across open ground. The tornado moved northeast, toward the southern suburbs of Oklahoma City, its forward speed and circulation size growing. The tornado moved northeast, toward the southern suburbs of Oklahoma City, its forward speed and circulation size growing. Power flashes erupted as lines snapped, and building pieces spiraled high into the air. Power flashes erupted as lines snapped, and building pieces spiraled high into the air. Miles away, a Doppler on wheels truck, a mobile radar system, drove directly into the severe weather's path to collect detailed data. Each radar sweep measured debris and rain motion, revealing wind speeds inside the tornado. The numbers were extreme, 150, then 200 miles per hour. But the next scan shocked them. The velocity spiked again, 250 miles per hour, then higher. The velocity spiked again, 250 miles per hour, then higher. Inside the Bridge Creek tornado, winds were moving faster than a Category 5 hurricane by nearly double. This circulation, one of Earth's most powerful, was still moving directly toward the city of Moore. This circulation, one of Earth's most powerful, was still moving directly toward the city of Moore. By early evening, the tornado approached Moore. Residents watched, meteorologists broadcast, and urgent warnings echoed. Large and extremely dangerous tornado. People rushed to shelters, closets, and cellars as the sky darkened and a massive, mile-wide wedge appeared. At around 5:30 p.m., the tornado reached the outskirts of Moore. Homes were struck, roofs lifted, walls ripped, well-built houses disintegrated. Cars were thrown, trees snapped, power lines exploded. Cars were thrown, trees snapped, power lines exploded. The Doppler on wheels wind measurements translated into raw destruction. Entire blocks were reduced to piles of lumber and twisted metal. Emergency responders mobilized as the storm crossed I-35, scattering traffic and raining debris onto the highway. The tornado continued tearing through Moore for miles, leaving it shattered, its residential grid scraped nearly clean. The tornado continued tearing through Moore for miles, leaving it shattered, its residential grid scraped nearly clean. As the tornado moved northeast of Moore, it reached its peak strength. Damage surveys revealed F5 violence. Homes removed, only concrete slabs remaining. Heavy vehicles were thrown, steel power poles bent, and trees stripped. All F5 indicators exceeding 260 miles per hour. Large sections of the track were classified F5. Schools, churches, and businesses were shredded. Debris carried for miles. Subvortices spun within the core, producing extreme winds and catastrophic damage in narrow paths. Storm chasers reported multiple swirling funnels, the entire circulation churning like a giant blender. Storm chasers reported multiple swirling funnels, the entire circulation churning like a giant blender. For residents, it was a defining memory. Sirens, roaring winds, and flying debris. A moment when the atmosphere showed its absolute limit. Radar data confirmed the Doppler on wheels' extraordinary values, more than 300 miles per hour. After nearly 90 minutes, the massive wedge slowly narrowed, fields replacing neighborhoods as it lost strength. Cooler air disrupted inflow, causing the wedge to collapse and the tornado to shrink into a thinner funnel. Debris fell, rotation weakened, and after a few more minutes across farmland, the funnel lifted. Debris fell, rotation weakened, and after a few more minutes across farmland, the funnel lifted. In the days after, scientists analyzed radar data, confirming the Bridge Creek Moore tornado's extraordinary 301 miles per hour winds. Researchers rechecked calculations and verified the data. The measurement was real. That measurement became the strongest wind speed ever recorded on Earth. Not in a hurricane, but inside a tornado. The discovery changed how scientists understood atmospheric limits, proving the atmosphere capable of greater violence than believed. The discovery changed how scientists understood atmospheric limits, proving the atmosphere capable of greater violence than believed. The Bridge Creek Moore tornado became one of the most studied storms, improving forecasting, radar interpretation, and warning communication. It proved the value of mobile radar, showing that without Doppler on wheels, the strongest winds might never have been discovered. The 301 miles per hour measurement led to the enhanced Fujita scale, refining damage evaluation and tornado strength estimation. Communities across Tornado Alley expanded storm shelters and early warning systems, learning the atmosphere's unimaginable power. Communities across Tornado Alley expanded storm shelters and early warning systems, learning the atmosphere's unimaginable power. The Bridge Creek Moore tornado lasted less than 2 hours, but its data will shape tornado science for decades. 301 miles per hour, the fastest wind ever measured on Earth. Inside a tornado,